For 12 points, can you guess the function without any information? Of course you can't. For 10 points, the function of which I am thinking now is a many-to-one function. Now, it's often noted that some many-to-one functions only bother with two values of x, leading us to one value of y. But this function is no such imposter, with more than two values of x giving rise to one value of y in some cases. For 9 points, this function is odd. And I'm referring here to its symmetry, which is that a rotation of 180 degrees about the point 0, 0 maps that function onto itself. It is not, however, an even function, which is a reflection of the y-axis, does not in this case map the function onto itself. It's odd like the number 57, but it's not even like 58. For 8 points, this curve cuts the x-axis at 3, 0, and I am sure the observer with intelligence will have quickly realised, based upon previous information you have received, that it cuts at minus 3, 0 also, as a consequence of being an odd function curve. For 7 points, this function also goes through the point with the coordinates of 7, 280, which is a very high point on the graph. For 6 points, function aficionados will be appreciative of the comprehensive attitude of the domain and range, as they both accept and produce all known real numbers from minus infinity to plus infinity in the x and the y directions. All numbers are up for grabs or for grabbing with this function. For 5 points, we're in the territory of the odd function. Now, this function is odd, not in a weird or strange way, but because it is a polynomial with an odd index. Like 5, but it's not 5. A different odd number, one that is not the number 5. For 4 points, we are considering a function which doesn't just cut the x-axis once, it doesn't just cut it twice, no siree, we're all about the 3 cuttings of the axis, un, deux, trois. That's because this function, under the consideration of us, is a cubic. For 3 points, you may have noted, you may not have noted, but whether you did note or did not note, it still holds that this cubic curve passes through the origin, the point 0, 0, the centre of all the graphical graphs. For 2 points, if you're into your counting, and I'm a big admirer of the counting, you would be able to count 2 terms in this function, one of them an x cubed term, which is why this function is called a cubic function, and the other term is an x term with no other index than the index of the 1. For 1 final point, this is a function which features the number 9, and in its factorised state has an x and 2 pairs of brackets containing the difference of 2 square stuff, with a 3 and a minus 3.